Hello everyone, welcome you my lecture series of Principles of Compiler Design. In this video, we have seen the topic on Automata Theory. So what is an Automata Theory mean? It is a mathematical model. It is a mathematical computational model is used to solve our real-time problems, and it is a set of processes. So there are the three basic concept of Automata theories are automata, language and grammar. So the automata theory is formed in terms of language, grammar and automata. So first we will see what is a language. So language it is a collection of string. The string is a collection of alphabet. Now we will see what is an alphabet. So alphabet is a finite set of symbols. It is a non-empty set of symbols. It is an alphabet. That should be only any one alphabet should be present in the particular set. It is called it as an alphabet. For example, we have a comma B comma C means only the particular set contains the three symbols. Next is a string. String is a over an alphabet. It is a finite set of symbols from the alphabet. It is called as a string. So we can derive the string from the alphabet. This call it as a string. For example, we have an alphabet A comma B comma C means what are all the strings we can derive from that. That is called as a string. So we can derive in terms of we can epsilon A B C. We can A B B C B C A and A C P. So we can derive n number of strings over an alphabet is called it as a string. Next is a language. The language is nothing but it is a set of strings over an alphabet. So it is a set of strings over an alphabet. It's called it as a language. So the language set contains. So what are all the strings we can derive from the alphabet? It is called it as a language. For example, in the string, the alphabet contains the three symbols A comma B comma C. So we can derive the string is epsilon A B C A B B C A and A C B means that is a language for the particular alphabet. That is difference between. So you know the difference between what is an alphabet, string and language. So language is constructed from the string. The string is constructed from the alphabet. Next is the grammar. Now we will see only the abstract view of grammar. In the next previous coming video, we will see the detailed terms of what is the grammar and types of grammar. Now, what is a grammar? Grammar is a set of rules called the productions which define a language by describing how the strings in that particular language can be constructed. So, how we can construct the strings in the particular language is called as a grammar. For example, using the grammar only, we have to derive the particular language. Okay, so the language is constructed from the string. Already we know that. So how we can be constructed? That is a rule. That is a set of rules. So grammar is a set of rules. That rule is called it as a productions which define a language. Okay, by describing how the particular strings can be constructed. So grammar contains the four tuples. We have a start symbol, non-terminus, terminus, and set of productions. So in the right side we have a example of the grammar. The grammar contains a set of productions. The productions should contain the terminus, non-terminus, and start symbol and the productions. For example, S tends to AS or BA or epsilon. A tends to small a, capital A or B. So these are all the productions describes how the strings should be constructed. For example, we have to construct the strings A, B means that string should be constructed using the grammar only. Okay, so you have the three types of grammars. One is the regular grammar, then context-free grammar, and unrestricted grammar. So these are all the three types that we will see in the next video. So next is the automata. So what is an automata? So automata is a computational model or machine. It is an abstract machine. It is a abstract machine is used to define the particular language. So how the particular strings can be be recognized. That is the automata. Okay, the automata, it is a set of rules called the transitions which define a language by describing how the strings in that language could be recognized. Okay, so we have the string like 001. That means that string should be recognized in terms of an automata. Okay, that is, for example, consider an automata for the symbol 0, 1 means. So we have the automata. It is a set of it is an and the transition diagram, it is a transitions. So the transitions should contains that we have that start symbol, then what is the final set of symbols, final state, start state, final state, and what are all the set of transitions from start state to final states. So there is a terms like there is a set contains the 5 tuples of automata is there. So consider we have that particular automata, we have the 3 states Q0, Q1 and Q2. So we have to recognize the strings 001. So that could be, for example, the strings start with 0 and end with 1. All the strings which can be derived from the particular alphabet should be recognized in the particular automata. So the automata is also 3 types. One is the finite automata, push-down automata, and Turing machine. So we will see that automata in detail also in the next session. So I hope you will understand. So what is the basic 3 terms in the particular automata theory? One is the language, grammar, and automata. So based upon only this computation model is designed. Thank you.